you're taught, grab the pen. You're taught f of x. And then your teacher was like, don't freak out. It's just y. Well, it's not really just y. It's function notation. It can cover for y. But the reason why we start learning about it in grade 10 is because when we get to grade 12, we can have a k of x graph, an h of x graph, and a g of x graph all in the same thing. If they're all y's, then I label them all as y's. Which one's which? I don't know. So you label them different letters, right? So if I have f of x equals 2x plus 1, this is grade 10. We do a lot of linear stuff in grade 10. Linear hugely in grade 10, quadratics in grade 11, then every function under the sun in grade 12. We just throw them all at you. We slowly build and then just everything else. Okay? So if I gave this to you in grade 10 and I said, okay, x is 4. What is y? You could say, okay, x is 4. So I go f of 4 equals 2 times 4 plus 1, and then it equals 9. So now I have f of 4 equals 9. In grade 10, you were taught that's a coordinate. I put in an x, I took out a y. In junior high, it's an input and an output. It's the same thing. You put in something, you get out something, correct? I put in the x, I got out the y. It's a coordinate, is it not? It's just function notation for a coordinate. It's nothing crazy. People feel overwhelmed with it. But this is equal to this. Those are the exact same thing. This is function notation of a coordinate. That is a coordinate. Function notation, coordinate. Nothing crazy. Nothing mind-blowing. They're the same thing. We agree? What if I did this? What if I had this? F of 3 equals 0. What is that? 3, 0. What is so special about 3, 0? When your y's are 0, what is it? X-intercept. When your y's are 0, it's an x-intercept, right? Okay. That was grade 10. Hello, here you are. Okay. Now we're in 12. There's something called the remainder theorem. The remainder theorem, when a polynomial p of x is divided by a binomial x minus a, the remainder is p of a. Cool. If the remainder is 0, then the binomial x minus a is a factor of p of x. If the remainder is not 0, then binomial x minus a is not a factor. Let's go back to grade 11. I'm telling you, all the math you've learned before is important. You need it. Okay? In grade 11, you were given like x squared minus 2x minus 3 equals 0. In grade 10, you were given this without the 0. Right? In grade 11, they somehow made it equal to 0. Because if they made it equal to 0 in grade 11, it was actually normally this. The moment you made it equal to 0, you were actually making y equal to 0, weren't you? Isn't that the same thing? You took a y, you tossed it out, you laid it in 0. When y is equal to 0, what are we finding? X-intercepts. That's what you did last year. You found them doing so many things. So you set it equal to 0. We've done that this year already. We set it equal to 0 and solved in terms and columns and binomial, right? When we used the NPR formula. So what did we do? We factored it. We got x minus 3. We got x plus 1. And then what did we do? So this was grade 10. Where I'm like, okay, cool, we're doing this, we're a factor. All we've done is grade 10. And then we do the one grade 11 step. What did we do after this? We've already done it this year. You just set them each equal to 0, correct? And voila, you have the two x-intercepts, don't you? So when you set a factor equal to 0, what are you looking for? You're looking for an x-intercept, aren't you? So we would say that these are factors of this quadratic, correct? Well, this year we're going to do cubics, quartics, quintics. So x squareds, x cubes, x fours, x fives. Nothing is crazy different about them. To be blatantly honest, you just have more factors. If it's an x squared, you have a maximum of 2. If it's an x cubed, you have a maximum of 3. It's 4, 5, right? Nothing, it's not overwhelming. Don't let it freak you out. It's literally the same thing. You just get more of those little brackets, right? We do synthetic division to do it. It's actually kind of fun. All right. So we knew that if we got this equal to 0, if we have this coordinate here, we know this is an x-intercept. True statement? We worked it back, it would have been a factor previous to it, yes? So, the remainder theorem just says that, I don't know what I just did, but it moved. The remainder theorem just says that if I find out what x equals, if I plug it into here, I'll get the remainder. If the remainder is 0, it's an x-intercept. True statement? If the remainder is 0, your y is 0, it's an x-intercept, therefore the factor is a factor of the polynomial. So what we did before. We could do long division. Remember long division? It was like 20 into 5,763,900, blah, blah, blah. And you do long division, yes? And then what was left over was your remainder. And you could write r, and then you put your little remainder, and it was like all satisfying. Okay? For polynomials, we could do remainder theorem for it. Or, remainder theorem actually just says that if you put what x is in for it, what comes out at the end, the output, is the remainder. So, if I have x plus 1, I'm not putting that in. I'm going x plus 1 equals 0, x equals negative 1. That's what I'm putting in. I'm not putting the factor in, I'm putting the root. Seeing if it's a root, seeing if I get a 0 when I put it in. So I'm going to go p of x equals, and I'm going to write out the equation because it doesn't have a p of x, so I want it to. So I'm going to write p of x because it's a polynomial, and I'm cool like that. Now I want to find out when I put in negative 1, what do I get? So I'm going to go p of negative 1 equals negative 1 cubed plus 4 times negative 1 squared plus negative 1 minus 6. And I get p of negative 1 equals negative 1. Negative 1 squared is 1. 1 times 4 is 4. Minus 1 minus 6. And so I get p of negative 1 equals negative 4. What did I just find if we go back to grade 10? It's just a coordinate, an x, y point, right? Put in an x, got in a y. Put in an input, got in an output. You guys did it in t-tables in junior high all the time. They were super long and monotonous, but you totally did them. So we put in an input, got in an output. So actually, I'm going to write this, but we don't have to write this, but I'm proving a point. There is a coordinate on this polynomial. The coordinate is at negative 1, negative 4. Very interesting. The remainder theorem states that whatever you fill in, whatever your y is, would actually be the remainder. So if I did this in long division, and I plugged in an x plus 1, my remainder will be negative 4. So if all they want is the remainder, we're going to learn how to do synthetic division, and the last number is always the remainder as well, right? You're going to be able to learn that as well. But if all they ask for is the remainder, poof, fill in the x, get out a y, there's your remainder, without having to do synthetic division. So this one here says, divide x cubed plus x squared minus x plus 3 by x minus 1. What is the remainder? Cool. Here's my possible factor. X minus 1 equals 0. I get x equals 1. And I do p of x again. Then I do p of 1. 1 cubed plus 1 squared minus 1 plus 3. And I get p of 1 equals 4. What did I indirectly find? What does p of 1 equal 4? What's another thing I could say with when I get p of 1 equals 4? No? The coordinate is 1, 4. That's just a side note. What is the remainder? Just 4. Ruh-roh. Now we have a 2x plus 5. Does that make it any worse, Sam? No. I'm pretty sure this hurt it too. 2x plus 5, you just set it equal to what? 0. Isolate x. negative 5. X equals negative 5 halves. So I'm going to plug that in. I'm going to go P of X equals. When you type it in, you get 2. It's actually kind of nice. So oh my God, it's just moved on. Oh my goodness. Okay. We have a coordinate at negative 5 over 2 and 2. But what's the remainder? Yeah, remainder equals 2. And we're flipping over. Why the heck do we even learn remainder theorem? We learn remainder theorem because of factor theorem. It's on the next page. The factor theorem is very similar to the remainder theorem, except the remainder is 0. The divisor, in fact, is a factor. So what the heck does that mean? If I get it equal to 0, my y is equal to 0. We agree? When my y is equal to 0, I found an x-intercept, yes? If I work it backwards, I have a factor. Remember, we did it in grade 11. We got factors and we worked it down to x-intercept. Now all I'm saying is if you have an x-intercept, if you work it backwards, you have a factor. So all you need to know is if they ask if something is a factor, verify that x plus 2 is a factor. You just use remainder theorem and see if you get a what. What number would let you know it's a factor? Says it right above it. 0. If you get a 0, it's an x-intercept. Therefore, x plus 2 is a factor. Because x plus 2 equals 0 would give me x equals negative 2. If I put negative 2 in and I get a y out of 0, it's an x-intercept, which means x plus 2 is a factor. So all you're looking for if something is a factor, the moment I see is a factor, I say remainder 0. I immediately write it above. I underline and I put remainder 0. And people who get this wrong on a test don't underline and write remainder 0. They're like, I have no idea what I need to do. So the moment I see factor is a factor, I'm like, and I go remainder 0. Because then I know exactly what I'm looking for. They're not going to say, is it a remainder of 0? They're going to say, is it a factor? Here, and I need to know, does that mean does it have a remainder of 0? So I plug it in, and I get f of negative 2, negative 2 cubed, plus 5 times negative 2 squared, plus 2 times negative 2, minus 8. And I get negative 8 plus 20, minus 4, minus 8. And I get f of negative 2 equals 0. Is that an x-intercept? Negative 2, 0? Yep. So is x plus 2 a factor? Yep. You're going to say x plus 2 is a factor because the remainder is 0. I have a tiny bit of homework. You're literally just saying if it's a factor or not. So you're going to see if it has a 0 or not. I'm going to go through...
To the front office, please.
Didn't deposit. I'm going to go through domain and range. Right here. 2BE, 3BDF. He's literally just asked, is it a factor or not? So you plug it in and see if it has a remainder of 0. That's it.